everyone. Welcome back to the channel. My name is Chris Norman. I'm an engineer, an entrepreneur, and an aviation enthusiast who loves sharing knowledge. To recap, when I was in high school, I flew radio-controlled airplanes, and I happened across a magazine for kit planes that on the front cover had a Lancair 4P, which at the time was a brand new aircraft. So ever since high school and ever since I saw that Lancair, I realized that I could build an airplane just like my radio control airplanes that would fly fast and was also fun to build and considerably cheaper than anything that you could buy off the shelf. So here I am. It's been a couple of decades, a couple of degrees, a couple of kids, and I bought my first Lancair kit. Actually, I bought two kits in January this year, and my early videos showed the journey and the saga from bringing that home, and you get to watch my progress in documenting the airplane and the design modifications and discussions about this famous aircraft, the Lancair 360, that is no longer in production. So during the videos, you're going to be learning about composites and building this amazing super fast airplane. There are a lot of these kits available, and if you look at the serial numbers in my kits, you'll see there are somewhere around 1,400 of them, 1,600 of them that were produced, unless Lancair skipped serial numbers. And you can pick one of these up depending on the stage that you find it in for way less than a cost of a new car. I've seen them go for between $7,500 and $2,500 without an engine, and they can go a little higher. I've even seen some that are in the $25,000 range with a rebuilt engine or an engine that needs to be rebuilt, and a lot of these are even on gear. But this is a challenging project, and if you've never done anything like this, it can be pretty difficult to do. So I'm hoping that not only with the videos that I can create some excitement around this vintage design that is considered by many in the aviation community to be very much like a Ferrari of the kit plane industry. And if you follow along and you learn how to build one of these airplanes from me, I'm going to try to be very detailed in my build plan so that we end up with a series of videos that would help you or help anyone to be able to build and fly and enjoy your own airplane. One of the big advantages of building your own aircraft is the cost standpoint. It's considerably cheaper to build the kit, but then beyond that, as your own builder, because it's an experimental and you are the builder, you are also allowed to perform all of your own maintenance. So that may be intimidating to some, but you can always have an A&P just look over your work. And this means you can cut down on the cost of flying immensely. And something else that's fantastic about the Lancair 360 is that this aircraft can fly with an 0320 sized engine or a 360 sized engine. And it gets incredibly good fuel efficiency going fast. You can easily get this airplane to fly on about 7.5 gallons an hour at just right around 200 knots. The bigger engine obviously has a little higher burn, and people get cruises in the 210 to 220 knot range. And with the 320, if you throttle back, somewhere closer to 180 knots on about a 7 gallon per hour fuel burn. And these figures are not exact, and it really depends on how you build the airplane, how true it is, how, if you have gap seals and lots of other little nuances. But generally, this is an amazing aircraft. My last video covered a high-level overview of 3D scanning using the Creaform HandySCAN Elite Black. For those of you who have been following along, I first scanned the aircraft with an Artec Leo 3D scanner, and I thought at the time that was going to be a right choice for this aircraft because of its portability and some other features. But that turned out not to be the case. So this video is the second part of a two-part series of scanning the Lancair and what I've done with all of the scan data. So the last video covered how to get the data into the computer, but I didn't spend any time talking about the actual workflow that, converting the captured data into something usable in a CAD program like SolidWorks. I also didn't address the fact that what the scanner you use and what software can make or break the success of the project. So I'm going to dive into those details. When I first chose to scan the Lancair, as I stated earlier, I chose to rent an Artec Leo scanner because of the features that it had, and I thought they were important. So for example, the Leo is completely self-contained. It has a hard drive and graphics card built in, as well as Wi-Fi, and does all the data processing right in the scanner. And it even has a screen so you can see what you're capturing without cables. So I thought that was really nice. It's battery powered and you could carry it around, capture all the data. You didn't have to have a laptop. And it also captured texture data, which I thought, to be honest, would be pretty cool. And you can see from some of my images here that you do get the data for the images that it scans along with it for the textures. And you can see the serial number inside of the fuselage. So that was really neat. But unfortunately, the Leo proved to have some shortcomings for what you might call metrology grade 3D scanning. The Artec Studio software, on the other hand, was pretty intuitive, but it fundamentally lacked the ability to align all of these multiple scans that I did for the fuselage of the aircraft really well. And that's because the Artec Leo uses texture data to do the alignment. It also turned out that the Leo scanner had something that I can only describe as drift, where it lacked the ability to scan lawn objects with a wing spar. And that's probably due to the fact that it only uses the texture data or texture of the surface that it's scanning in order to stay aligned. It also had a lot of difficulty when I scanned the cowling for the airplane, and walking from one side to the other, it literally lost reference and the bottom half of the cowling was distorted as a result. So what I learned was that the Leo only aligns with the texture, and the software has features that says use target, but nowhere in any of the videos online or anything said anything about how to use the dots, nor does Artec actually provide anything like that I could find. So it's a little bit of a hit or miss with that. And in the end, what I decided was that the features that the Artec Leo had really sounded terrific. Cable-free scanning, wireless streaming of the scan data, a screen to see what you're doing. But in practice, the Leo is good for, in my opinion, smaller objects with lots of geometry, like an engine, for example, or a motor or a heat sink or something like that. Although I did not try it, I suspect that if I used a marker to draw squiggly lines all over the plane, that the Leo would have been able to triangulate all those marks and provide better results. But I didn't really want to mark up my aircraft, so perhaps it might also work with targets, but I suppose I'll never know. So that brings me to the software. The Artec Studio version 16 software is a very intuitive program, but it also has very few bells and whistles. The different alignment methods in the software are a bit cryptic and confusing. As I went through even the instructions provided, I really couldn't make heads or tails about what they really represented. And even as an engineer, a very technically minded individual, I really had a difficult time with that. And many times during my work, it even made the scan data worse using certain alignment methods that I found in the software. And I had better results manually aligning to get the scans close. And then once you have the scans close, you can click a button to say finish the alignment. And if you get it right or get it close, it'll do a pretty good job of lining them up. I guess it's comparing all the points that you captured with the points in additional scans. But the bottom line was the Artec Leo or Artec Studio software. I felt like it lacked refinement for workflow, for engineering, and it had challenges when capturing and combining multiple scans. And unfortunately, without the use of targets, it loses reference often while you're capturing large objects like the fuselage of an airplane. So I spent about maybe a little more than 2 months trying to convert the scan data into something usable in the Artec software before someone online in Facebook suggested that I investigate a Creaform. In the last video, I showed the scanning process of the Creaform HandySCAN Elite Black, but if you listen carefully at the beginning of that video, I also tried to use the Creaform GoScan before we tried the HandySCAN, and that one also uses texture data, and it encountered the same kind of problems. And we think that that might be, after talking it over with Creaform, that it might be the translucent nature of the fiberglass that actually causes the problem, because the scanner picks up artifacts at different lighting angles by going right through the translucent fiberglass. This was really dominant in the window area. We kept getting artifacts when we were scanning, and I resorted to even closing down the door to the hangar in order to see if that would have an impact, and it did. But ultimately, after a bunch of attempts, we had to switch to the HandySCAN, which is a completely different animal, and it's a laser-based capture device, and it's considered to be a metrology grade 3D scanner. So with that, we basically made the plane look like it had measles with these dots all over it, because the Creaform HandySCAN Elite Black scanner only captures the reference points that are presented from these targets. So they have to be put all over the plane, and they have to be in random patterns so the software can figure out and triangulate just strictly off of those. VX Studio and VX Elements are Creaform's software for post-processing. In part 1 of the video for 3D scanning, you could see that the results of the HandySCAN Black Elite from Creaform performed flawlessly, and we ended up with a beautiful model that I could use to create surfaces in their software in order to do modeling from. So VX Studio and VX Elements are Creaform's software version of the Artec Studio software for post-processing the 3D scan data. And as I mentioned, someone suggested that I try this scanner and software because it was far better than the Leo software, especially when it comes to surfacing. Now, surfacing is the process of taking 3D dots in space, which is what the 3D scanners capture, and converting it into a mathematically derived surface that goes through all of those points. And this is required in order to do any CAD modeling off of the model that you capture. So what you end up with is something that is not a bunch of points in space any longer, but is a mathematically derived surface that actually flows through like an average of all of those points. And that leads us into the question of why so many people are probably wondering why I did all of this scanning. And I just hinted on this in the middle of the first video. I hinted at this, and I'll go into more detail in a subsequent video where you'll be able to see how I used all of this scan data to do customizations on the design. But at this time, we're just going to focus on the software and the post-processing, because I feel like that's something that would benefit a lot of people in the aviation community. So after a short learning curve in VX Elements, I was off to the races creating surfaces. And I found that there is a tool for automatically creating surfaces, which I tried to use at first because I hoped that it would create, the surfaces that I wanted, but it just could not get the fuselage right. And I realized I'd have to use the manual mode because automatic surfacing just couldn't pull it off. It actually creates hundreds or thousands of these little patched surfaces. And it just couldn't manage all the complex curves of the fuselage. So it probably would be ideal for something like a car hood or something, maybe less complex. But scanning both the inside and outside of a complex object like the fuselage of the Lancair, I found that manual surfacing was really the only way to get what I needed. And I did encounter some errors as I pushed this software to do more complex geometry in manual mode. The problem I encountered with manual surfacing was that after saving my progress, sometimes the software would fail to let me continue. You could exit your progress and then come back in. And even though you could open the file, you just wouldn't be able to drop back into the edit mode where the progress had been saved. And it turned out that I was able to keep moving forward by just duplicating the surface as a new object, but trying to re-edit the old data would just make the work disappear. So I made Creaform aware of this, and they have assured me that they'll be working to resolve this in an upcoming release. Another amazing feature that I found with the VX Element software was surface and primitive object creation for reverse engineering. And this is probably useful to a lot of people. There are videos on YouTube that show this process, but I felt like none of them really explain exactly what you do with these tools and how you combine them with cross-sectional data to reverse engineer an object well. So I'm going to provide some examples of how these tools work for scanning something complex like an aircraft. So for example, someone recently reached out to me asking about scanning the cabin of a Cessna 172 without the instrument panel installed in order to determine where the location and space for all the hard points for mounting an instrument panel. Likewise for door panels and other interior trim. And this would be very easily accomplished with a scanner like the Creaform HandySCAN Elite Black. And then being able to quickly create planes where those surfaces go for mounting and where bolt holes go, and also being able to create simple objects like tubes and flat surfaces, so to create reference points for the mounting hardware. So my research and actually doing the scanning led me to understand that there are a lot of different scanners from each one of the scanner providers, and the scanners are all designed to fill certain gaps in scanning processes. Some are designed to capture high detail in very small envelopes like on a tabletop, but those are ineffective at capturing large areas. Other scanners can capture medium-sized structures like the Lancair fuselage or a boat hull. But they have other models which are designed to capture even larger objects like the outside of, say, like a jumbo jet. And even beyond that, there are 3D scanners designed to capture entire buildings or like inside of a petroleum plant, or what I would call architectural scanning. So in the end, after all of this, the fun part is that 3D scanners can be rented. Depending on the model, you can usually find them for between a few $100s up to $1,000. The Arctic Leo that I first rented was about $500 a day, while the Creaform HandySCAN Black Elite, I think, rents for slightly more, like maybe $600 a day. And that said, that the rental places don't really treat a day like you think. Most renters consider the next day to be the full day. So if you pick up the scanner at, say, 2 p.m. and go start scanning on a Wednesday, you would have all afternoon, evening, and night, and then the entire next day to do all of your scanning. And the company that I rented the scanner from even said that it was acceptable to return the scanner the following day as long as it was there by 8 a.m. So that means you could realistically have the scanner for like 36, 38, 40 hours for that single charge, which is pretty reasonable, I believe. It came out to something like about $16 an hour. That's pretty cheap in my book. So the hard part is that not all cities might have a place for you to rent a scanner from. So you need to locate a rental company. Most places that do rentals will usually ship the scanners out, meaning you can FedEx the scanner to you. It'll likely arrive in a Pelican case along with a laptop that's been that has the capture software pre-installed and the charger cables. And the learning curve really isn't that hard. You could figure it out by going on the internet and just watching some YouTube videos. And the post-processing is what takes a bit more time. So you should work with your scanner supplier to ensure that they'll give you a license on loan after you do the scanning, so you can install it and post-process the scan data on your home computer. Trust me, it will take some time to do the post-processing. Even if you hire someone to do it, both Artec and Creaform worked with me to have software at home to post-process the data. Otherwise, the rental would be futile, in my opinion, for anything other than very small projects. So lastly, in my opinion, there's a financial aspect to consider when you rent a scanner. You either get what they call a commercial rider insurance policy that covers the total loss of the scanner while it's in your possession, or you have to take total responsibility yourself for the rental. I think that that's kind of a scary proposition for a $65,000 scanner like the HandySCAN Black Elite, and along with the $3,000 laptop. So this was probably the most challenging thing I worked through at the beginning, trying to find an agency that would do what they call the commercial rider policy for just a few days. That turned out to be really hard. Most of them want to do it for a month or do it for 6 months or a year. And but after searching for a few days, I finally found a company to provide a commercial insurance rider online, and the process was really straightforward and simple. I think in the end, it only cost me around $50 for coverage for a week. And I'll post a link in the video to the company in the comments below. It was super easy. I applied through their website, provided the make, model, and serial number of the scanner, and they treated it like a piece of surveying equipment, which is what they felt like it was the most equivalent to. And I kind of explained to them what it was, and they probably are going to add it to their repertoire of things online. I found it by looking up rider policies and looking for industrial equipment rentals, because people rent things like forklifts and backhoes and stuff like that all the time. And I found a company that did rider policies for rental surveying equipment. So I picked up the scanner the same day that I did the rental at about 1 p.m. that day, and I was scanning by 4 p.m. I scanned with the help of my son late into that night and packed up and returned the scanner the following day. So we had that night, the full day, and then around I came back 9 a.m. on the second day and scanned all day to get all the objects that I wanted. So my project was perhaps larger than a lot of people's would be if they were just after one object. And then I drove and dropped off the scanner the following morning to the location by 8 a.m. I was waiting, and they took it back. There were no issues. And then they gave me a copy of the software to do the post-processing. It's not a piece of cake, but if you're able to play video games on a PlayStation or use your cell phone for more than phone calls, you can probably figure out how to do the scanning. Of course, there's a lot of other videos on scanners and manuals online too, so I would recommend that you do your research ahead of time and plan ample time to scan. For the Creaform HandySCAN, you must have targets, and the renter should have these available, and they do cost money. I think they're like $40 a box. There's like 5,000 of them in a box, or 1,000. And I would argue that you should not skimp on the dots. That'd be the worst case scenario where you rent it and you get poor scan data because you skimp on the dots. You should have something like 3 to 5 dots in any given 1 foot patch of surface if you want to remain really accurate. And they should be in complete random locations, not regular patterns or intervals. Of course, other Creaform products don't require the dots, such as the GoScan, which we attempted first, but we really didn't have success with that on this object. So you should also talk to the scan location about what's the best choice of scanner for your object. So I would argue that I'm also told that the Creaform HandySCAN Elite Black will scan even chrome or glass objects because it's laser based. So you might want to consider that, not messing with some of the other scanner types like the texture based ones. But in the end, also just be prepared to contort your body into all kinds of positions that you didn't know you could do. And you might be a bit sore the next day from it. I know I was. And in the end, the experience for doing the scanning was really great. I learned a lot and obtained extremely accurate data of the Lancair. If I had to do it all over again, I probably would make sure the scanner I rented was optimal for the size envelope of the object. I wanted to scan by explaining to the rental agency what I'm scanning. Keep in mind that translucent objects can be a challenge with some scanners, especially the ones that capture texture. So fiberglass, like I mentioned with the Lancair, didn't seem to like either the GoScan or the Leo, and expect to spend between $500 and several $1,000s on the overall project and rental. If you're having it shipped to you, I would argue that you should be using FedEx Red same day or FedEx overnight with guaranteed 10 a.m. delivery to save money by reducing your rental period. And if you live in a big city or near one, it might just be easier to locate your scan into that city and do the work locally. I live in Houston, so I had access to both the scanner in town and the hangar. I hope this video has been helpful and that you've learned that you can get very accurate CAD data to help you with your project. Next up, I'll be doing a video about the actual use of the software and how you can generate primitives and hard points and surfaces that you can use for reverse engineering. And I'll also be doing a segment about turning the CAD data into tooling molds for carbon fiber parts. I personally do not have a CNC router table at home, so I'll be using a 4x8 foot CNC tabletop router at my local makerspace to cut the tooling board for my molds. And this was easier than the scanning because makerspaces offer classes and help, as well as providing the software in their shops. And that's a good point, that some makerspaces also have 3D scanners. So you might want to check out your local hacker or makerspace to see if they have one as well. I realize this video is very technical and not everyone may have the skill set to do the work themselves, but luckily that part I covered too, or maybe in my next video. And as always, if you have any questions, please feel free to drop them in the comments. In most rental places also offer scanning as a service for a fee. So if budget is not as critical, you can hire their technicians and they can do the scanning for you. You won't need a commercial rider policy to cover damage or loss because the technician will be in possession of the scanner. And yes, they are accustomed to traveling to sites to do the work. They'll get on airplanes and go do the scan, stay in a hotel, whatever you'd like. But these are additional expenses. And you can bring the parts to their shop to be scanned in-house, and the data can be provided back to you on a portable drive. Basically, there are just lots of options here. I did this work because I wanted it for my project and for posterity to preserve the Lancair 360 since it's technically out of production and there are a lot of kits out there, but a lot of them are missing parts. So a lot of people spend time on websites doing bartering and trading and buying of parts. Some of them are difficult to reproduce, and frankly, I wanted to do a lot of modifications to mine.